Hello 108 students, Mr. McCue back here for section 9.7. We're working on page 6, working our way through here. We are now going to tackle solving rational inequalities that contain a rational expression, and they are going to look a little complicated to begin with, but if we can follow these 5 steps we have listed here, I'd like to review them. I think we'll be able to sort this out a little bit. You're going to take the rational inequalities and make sure that 0 is set on one side of the equation and a single fraction is on the other. So we want to keep in mind it has to be a single. So we might have to do a little bit of work there. But once we've got the single rational expression set to one side of the equation with 0 on the other with the inequality signs, we're going to take the entire numerator and set it equal to 0 and solve for x. That's going to be one of our roots or solutions. Next, we'll do the same thing with the denominator. We'll set it equal to 0 and find the roots or the values of x that make it. Keep in mind, when we have that denominator, that final rational expression, whatever values of x that make that denominator equal to 0, we have to exclude. Remember the restrictions. We are never allowed to divide by 0. Okay, once we've armed with that information, so that's a little bit new, we will now follow some similar steps here where we will mark the x-axis and mark off the x solutions and identify the 3 intervals like we've done before. A will be the left outside, B will be the middle, and C will be the right outside. Again, we're talking about quadratic equations here. Step 4 talks about determine the intervals. It's either going to be the pairings A and C or B. And the key step to here is choose to let x equal 0 when you're doing your interval testing, and make sure you remember what interval that is. And you'll see this here as I work through this example 5. It's not always in the middle with interval B like we've done before. Okay, just put an extra star next to that, and we don't forget that. Okay, with that said here, let's go ahead and take example 5 and see if we can walk through the steps here. Notice what I've done here is as we start these, the step numbers 1, 2, 3, 4, 5 will match the 5 guideline steps before. Okay, so here we go. We're going to start our rational inequality. We've got -1 divided by the quantity x minus 3 is greater than 1. You notice that you do not have a 0, so we are going to subtract 1. Subtract 1 on both sides, and lo and behold, we are now left with the rational expression -1 greater than 0. Notice we do not have an equal sign here. Okay, now we need to get a single rational expression. So now we've got to deal with, we've done this before, got to come up with a least common denominator. So we've got to realize that the x minus 3 is part of the is part of the least common denominator. And so with the -1, I need to multiply it by x minus 3 stacked on top of each other. And when I've done that, that will give me a least common denominator, which we will combine down in here to the x minus 3. Okay, now be careful with the minus signs up here. You've got -1, which is going to come down here. And now we're taking a -1 times x and a -1 times -3, the distributive property. You get your -x plus 3 all greater than 0, again divided by the least common denominator. Up in the numerator, you've got -1 plus 3, which gives you a +2, and your -x comes here. And now you've got it in the form of a single rational expression greater than or equal to 0. Okay, so that's the new part. Creating a rational inequality with a single rational expression on one side and a 0 on the other takes a little bit of work here. Next step now perhaps seems a tad foreign, but now what you're going to do is take advantage of step 2. Tells you to set the numerator and set it equal to 0, and then take the denominator and set it equal to 0. And so when you take -x plus 2, set it equal to 0, watch the signs as I notice here, you get x equals 2. Okay, that's cool. That's going to be one of your solutions where it crosses the x-axis. Down in the denominator, when you set x minus 3 equals 0, you find x equals 3. Now we got to be real careful about this. Notice here that down in the denominator, when x equals 3, 3 minus 3 equals 0. So what we should have here is while 3 is where the parabola goes through, this needs to be an open circle. Please make a correction there on your notes there. Okay, so you got to watch that. Next, we're going to go ahead and draw the parabola. We can start up at the top, come down, go through 2, go through 3, and come up. Notice here real quick I put the little star. Now this is where your y-axis goes through here, and I've done this before. This is optional. This is your y-axis, but 0 is in the interval A. Okay, not in B, but it's in A this time. So we are going to go ahead and test for interval A and for C, because they both now are going to be above the y-axis. We're testing for that, and x equals 0 is in zone A, so we put 0 in. Make it easy on yourself. Always use this x equals 0. I know I keep overemphasizing it, but don't pick anything hard. Put 0 in. You watch your signs, put 0 in there, and you find out that you get the result. Positive 2 divided by negative 3, which is a negative 2/3, is that greater than 1? And the answer is no. However, look at my notes right here. You want to correct this. I say the test fails. That's true. However, what interval did we test? Not B, but we tested interval A, because x equals 0. You got to watch that. I'm glad I kind of made that mistake. I fixed it on your handout notes, but you want to realize that is interval A. So therefore, A and C are not your solutions, the intervals, but B is. So our final solution here is the bottom. I'll try to go overemphasize it here. We are really working on the bottom. We are going between 2 and 3. Again, we are not including those values because we do not have the equal sign with the inequality, and we have taken care of the restriction that 3 is not included. So it's between, x is between positive 2 and negative 3. Okay. Again, finally, this would be your interval notation here. Parentheses 2, comma 3. Remember, we're talking interval notation, not ordered pairs. Okay, Mr. McCue here. We are wrapping this section up here, page 6. We got one more to do, and we'll be good to go. Okay, I'll catch you later on page 7.